Okay, here we go again. I am not an expert on satellite missions. I have used satellite data extensively and published a few papers as well, but I'm vaguely aware of all the details of, the instruments, the orbital configurations and processing, atmospheric correction. There are ways in which the measurements by the satellite's instrument are converted into data, and those are the algorithms that take care of what prevents the signal from the surface reaching the satellite. Could be dust or clouds or water vapor and so on. And there are some instruments that can see through the clouds and so on. So let's read this. I'm doing just starting by saying I'm not an expert because somebody asked me to do this, and I thought I will go ahead and take the material from JPL and ISRO and provide just a brief introduction. This is from JPL Caltech, which says 5 things to know about powerful new US-India satellite NISAR. So this information is the NASA-ISRO synthetic aperture radar mission NISAR. The data will aid in managing agricultural fields, monitoring volcanoes and tracking land-based ice, including glaciers. So we'll read a few more details as we go along. What's the definition? This is AI generated based on the Handbook of Power Electronics in Autonomous and Electric Vehicles from a Elsevier journal or a book. Synthetic aperture radar is defined as a radar imaging technique that employs a moving radar system to produce high-resolution images by utilizing the motion of the radar antenna and advanced signal processing to simulate a larger antenna. This method allows for the collection of radar data from various observation points, enabling the creation of detailed images and three-dimensional information about the environment. So synthetic aperture radar from the NASA website, SAR, is one of the powerful technologies of remote sensing, and enables high-resolution imagery to be created night and day regardless of weather conditions. So clouds are not an issue for this. So basically, if you all know radars, they are sitting there somewhere and tracking storms and weather systems, and of course there are different bands, X, L, C, P and so on, S, which are used for various applications, including tracking enemy aircrafts and so on. And then you have radar evading stealth aircrafts, etc. But coming back to Earth, what basically happens is there is a satellite along its flight path, and it has an antenna with a dimension of L and D, and radar is an active pulsing, sends out a pulse and measures the signals. So it is a nadir track, which is basically looking directly down the satellite, and azimuth is basically the angle away from nadir, could be horizontal in both directions. So we are looking here as an example of a footprint of the SAR, synthetic aperture radar, which is flying along on a satellite. Synthetic is the key word because you are creating high resolution data from relatively low resolution pixels by using the techniques, advanced data signal processing techniques here. So you have elevation beam width as increases as you come down to the surface which you are trying to observe. It has a swath width, and it has azimuth and range, so it can swing in these directions, and there is a pulse duration of T, and there is an interpulse period. So you are sending out pulses of a certain period duration, and each pulse is separated by interpulse period. So the footprint is here, and the azimuth bandwidth is there. So the beam width and the bandwidth are related to the antenna dimensions or size. And the idea is a satellite cannot carry a massive antenna because it requires a lot of power and energy to stay in the orbit, and deploying it can be structurally complicated as well. So you want to optimize the radar size and have the synthetic aperture work in a way that produces high resolution images by using these techniques. So in a very simple way, that's what it is. This is from India Today Digital, so data will be freely available for global research. As we'll see, it's an artistic rendition of how the satellite will deploy this radar, the antenna, and then how it will begin to measure the things. NISAR, NASA-ISRO synthetic aperture radar, world's first dual frequency radar imaging satellite, largest ever spaceborne radar antenna, 12-meter gold-plated mesh that you can see here and here in terms of artistic representation. It can orbit Earth every 97 minutes, 14 orbits per day, so you can imagine how many time slices you get. The idea would be to get the diurnal cycle. So if rainfall has a diurnal cycle, then you want to measure enough times in a day that you can know how it's working. It can detect surface changes as tiny as 1 centimeter across huge regions. So this will help with sea level and landslides and other hazards, as we will see. It will map entire Earth's landmass, ice sheets every 12 days. All of Earth's landmass and ice sheets will be covered entirely in 12 days. Okay, so obviously there are details as to how many times it will visit the same point in a day, so that you can construct something, versus in how many days it takes to cover the entire globe. So the resolutions will depend on those kinds of details. Data from NISAR will map changes to Earth's surface, helping improve crop management, natural hazard monitoring, and tracking of sea ice and glaciers. So I'll read some examples of these from NASA's material. A new US-India satellite called NISAR, NASA-ISRO synthetic aperture radar, will provide high-resolution data enabling scientists to comprehensively monitor the planet's land and ice surfaces like never before, building a detailed record of how they shift over time. Hailed as a critical part of a pioneering year for US-India civil space cooperation by President Trump and Prime Minister Modi during their visit in Washington in February of 2025, the NISAR launch will advance US-India cooperation and benefit the US in the areas of disaster response and agriculture. It's set to be launched by ISRO on July 30th, and I'm recording this on July 29th. So we are right there. Success. As the first joint satellite mission between NASA and the Indian Space Research Organization, ISRO, NISAR marks a new chapter in the growing collaboration between the two space agencies, years in the making, decade actually. The launch of NISAR builds on a strong heritage of successful programs, including Chandrayaan-1 and recent Axiom Mission 4, which saw ISRO and NASA astronauts living and working together aboard the International Space Station for the first time. So the Indian astronaut went up and is already back on Earth. NISAR actually has a meaning. I'm not a Hindi speaker, so obviously I'm a bit clueless, but let's do this in real time. What is NISAR? But it will just say, oops, what is the, why didn't I do it before? I was just lazy. So NISAR, name NISAR means sacrifice, devotion, offering. Arabic Persian name used in Muslim communities, etc. Okay, so I don't know if that's what they had in mind, but nonetheless, here we go. The NISAR, so what are the 5 highlights? NISAR satellite will provide a 3D view of the Earth's land and surface, which is what synthetic aperture radar is good for. 2 synthetic aperture radars aboard NISAR. So there are 2 radars. So then as you go along and do all this nice azimuth footprinting, you can synthesize them together to produce much, the actual image produced will be high resolution, as if there was a much bigger radar flying. That's the advantage of a synthetic aperture radar. Okay, the what did I say? The 2 synthetic aperture radars aboard NISAR will detect changes in the planet's surface down to fractions of an inch Imagine. The spacecraft will bounce microwave signals off Earth's surface and receive the return signals on a radar antenna reflector measuring 39 feet or 12 meters across. The satellites, the larger the radius, the better, smaller is your footprint that you are capturing. The satellite's ability to see through clouds and light rain day and night will enable data users to continuously monitor earthquake, landslides, continuously monitor earthquake and landslide prone areas and determine how quickly glaciers and ice sheets are changing. It also will offer unprecedented coverage of Antarctica. Covering poles is always challenging. This information will help with studying how the continent's ice sheet changes over time. Secondly, data from NISAR will provide critical insights to help governments and decision makers plan for natural and human-caused hazards. So earthquakes, volcanoes, and aging infrastructure can pose risks, obviously. NISAR can help with hazard monitoring efforts and potentially give decision makers more time to prepare for possible disasters. For earthquakes, NISAR will provide insights into which parts of a fault slowly move without producing quakes and which are locked together and could potentially slip and cause earthquakes. Satellite will be able to monitor the area around thousands of volcanoes, detecting land movement that could be a precursor to an eruption. When it comes to infrastructure such as levees, aqueducts, and dams, NISAR data collected over time can help managers detect if nearby land motion could jeopardize key structures and then assess the integrity of those facilities to see if any damage has happened. Thirdly, the most advanced radar system ever launched as a part of NASA or ISRO mission, for both of them is the most advanced. NISAR will generate more data on a daily basis than any previous Earth satellite from either agency. So about the length of a pickup truck, NISAR's main body contains a dual radar payload, an L-band system with a 10-inch or 25-centimeter wavelength, and an S-band system with a 4-inch, 10-centimeter wavelength. So you have to figure out what this means in terms of what can be measured at what resolution. Each system is sensitive to land and ice features of different sizes and specializes in detecting certain attributes such as moisture content, surface roughness, and motion. So it's not a radar that's measuring rainfall, because S and L bands are meant for all these things we are talking about. By including both radars on one spacecraft, a first such configuration, NISAR will be more capable than previous SAR missions. These two radars, one from NASA and one from ISRO, and the data they will produce exemplify how collaborations between spacefaring allies can achieve more than either would alone. The radars will generate about 80 terabytes of data products per day over the course of NISAR's prime mission. That's roughly enough data to fill about 150 512 gigabyte hard drives each day. Information will be processed, stored, and distributed via the cloud and accessible to all. This is really critical because people know that sharing data is not always guaranteed. This is an artist's concept depicting the NISAR satellite in orbit over central and northern California. We saw another version of this before. The spacecraft will survey all of Earth's land and ice-covered surfaces twice every 12 days. So this resolution in time allows people to see what can actually be done in terms of analysis, and then what are the near real-time opportunities to manage hazards, monitor potential volcanic eruptions, earthquakes, etc. The fourth one, the NISAR mission will help monitor ecosystems around the world. The mission's two radars will monitor Earth's land and ice-covered surfaces twice every 12 days, as we said. Their near comprehensive coverage will include areas not previously covered by other Earth-observing radar satellites with such frequency. The NISAR satellite's L-band radar penetrates deep into the forest canopies, providing insights into forest structure, while the S-band radar is ideal for monitoring crops. The NISAR data will help researchers assess how forests, wetlands, agricultural areas, and permafrost change over time. Finally, the NISAR mission marks the first collaboration between NASA and ISRO on a project of this scale and marks the next step in a long line of Earth-observing SAR missions. The NISAR satellite features components developed on the opposite sides of the planet by engineers from ISRO and NASA's JPL working together. The S-band radar was built at ISRO's Space Applications Center in Ahmedabad, while JPL built the L-band radar in Southern California around Caltech in Pasadena, after engineers from JPL and ISRO integrated NISAR's instruments with a modified ISRO 13K spacecraft bus and tested the satellite. ISRO transported the NISAR to Satish Dhawan Space Center in May 2025 to prepare it for launch. We'll be monitoring it tomorrow. The SAR technique was invented in the US in 1952, and now countries around the globe have SAR satellites for a variety of missions. NASA first used the technique with a space-based satellite in 1978 on the ocean, observing CSAT, which monitored sea levels, which included the first space-borne SAR instrument for scientific observation. CSAT is sea state, which is, high, the waves and so on. And then it's processed to derive sea level as well. Was short-lived but produced incredible data and was a good demonstration of what can be done. In 2012, ISRO began launching SAR missions, starting with radar imaging satellite RISAT-1, followed by RISAT-1A in 2022 to support a wide range of applications in India. ISRO serves India's disaster management, search and rescue, monitoring various things like wildfires, etc. More about NISAR then. Managed by Caltech in Pasadena, JPL leads the US component of the project and provided the L-band SAR, as we said. JPL also provided the radar reflector antenna, the deployable boom, the stick that we saw, a high-rate communication subsystem for science data, GPS receivers, a solid-state recorder, and payload data subsystem. NASA's Goddard Space Flight Center manages the Near Space Network, which will receive NISAR's L-band data in Greenbelt, Maryland, where I spent almost 8 or 9 years. The ISRO Space Applications Center is providing the mission's S-band SAR. The U.R. Rao Satellite Center is providing the spacecraft bus. The rocket U.R. Rao is a famous space scientist from the state of Karnataka, where I belong. I met him many times because he was also working on the governing council of the Indian Institute of Tropical Meteorology, and I used to be on the Research Advisory Council, so we reported to the GC and so on. The rocket is from Vikram Sarabhai Space Center. Launch services are through Satish Dhawan Space Center, and satellite mission operations are by the ISRO Telemetry Tracking and Command Network. The National Remote Sensing Center is responsible for S-band data reception, operational products generation, and dissemination. So what does it do? An unprecedented view of Earth. NISAR's data can help worldwide better manage natural resources and hazards, as well as providing information for scientists to better understand the effects and pace of climate change. It will add to our understanding of our planet's hard outer layer called its crust, which is helpful for volcanoes and earthquakes. So mainly Earth's dynamic surface and interior, Earth's cold regions or the cryosphere, terrestrial ecosystems as we mentioned, and water. So obviously critical, water is very critical. So solid Earth, NISAR's global and rapid coverage will provide unprecedented opportunities for disaster response like landslides, providing data to assist in mitigating and assessing damage with observations before and after disasters in short time frames. Near real-time data is critical. Addressing and increasing exposure to natural disasters. So some background props are used, but you can see this is probably a semi-active volcanic mountain with glaciers around it. Glacier lake outflow glacier lake outburst, whatever it is. Okay, mitigating disasters and sustaining resources. benefiting forecasting, response, and resource management. So, because NISAR's data will be open access, more policymakers worldwide will be able to use them to meet scientific, societal, and commercial goals than can use other data that are not as accessible. So here is a prop used. I think this is from some part of California as well. Rapid, detailed damage assessments will be possible. NISAR will determine the contribution of Earth's most variable biomass to the global carbon budget and characterize ecosystem disturbances and impacts on biodiversity. That's the vegetation part. And I skipped the cryosphere part because we already mentioned that it will map the entire world's cryosphere twice every 12 days, and that will allow us unprecedented details on changes in ice, the glacier masses, and maybe mass balance and the various details that we can look up later. Okay, what does it do for water? A large percentage of the world's population resides near the coasts and derives its livelihood. Sorry, I've got a frog in my throat. Derives its livelihood from the coastal environment, and much of the global economy relies on the ocean to do business. So the resolution matters whether you resolve the coasts or not, because 90% of the fisheries are caught in exclusive economic zones 200 miles off the coast. We must capture them in great detail. With so many lives depending on our coastal regions, it's important to understand the nature and magnitude of coastal processes through periodic mapping of shoreline changes, ocean currents, wind velocities, ship locations, and oil spills. So it will also do land use change, erosion, etc. NISAR will also be capable of measuring changes in groundwater reserves across the land. Basically, this is similar to GRACE, where the Gravity Recovery and Climate Experiment satellites, two satellites flying together, detect small gravity changes, gravitational pull changes, and then they estimate glacier mass, groundwater mass, and so on, and many good papers have come out of that. Climate change coupled with growing populations is causing increasing stress on groundwater resources globally. By measuring changes in Earth's surface, we can understand processes occurring below the surface. Subsidence is often the first indication of changes in reservoirs or overexploitation of aquifers. So every time there is a massive extraction of groundwater, land subsides, and the satellite can actually measure it. Amazing, right? Amazing. So subsidence is often the first indication of changes in reservoirs or overexploitation of aquifers. Subsidence that continues for too long can lead to irreversible collapse of the aquifer system. Informed decisions allow us to make the most of our resources sustainably and economically. Basically, groundwater recharge happens at a very slow time scales, and it has built up, let's say, over geological time scales, and we can suck it out like Coca-Cola in a much, much more rapid anthropogenic time scales of few decades to even sometimes few years, because some parts of the world, like Northwest India, are extracting meters of groundwater every year. And if subsidence happens, maybe the ability to recharge can be irreversibly collapsed. NISAR's unique combination of radar, frequent orbit passes, and polar orbit also mean that the satellite can be used to study floods, precisely measuring every small change of water level in areas with standing vegetation. NISAR will provide systematic measurements across entire aquifers, the ability to map surface deformation of a few millimeters monthly over large areas at resolutions of a few tenths of meters. So few millimeters in the vertical, tens of meters in the horizontal. This has opened up new possibilities for remote monitoring of groundwater resources, which is seriously needed. Managing water globally, NISAR offers the promise of extending these observations to regions of the world with no effective means to monitor the state of the groundwater. This would provide information to large segments of the global population dependent on groundwater to bridge gaps in surface and rainwater supply. It may allow us for the first time to indirectly measure the volume of groundwater that is pumped and recharged around the world at a very fast time scale, which is desperately needed. This will become more important as Earth's changing climate and the growing global population outpaces the world's supply of fresh water in aquifers and, of course, the rate of groundwater recharge. Mapping floods, then, another capability of NISAR is its ability to easily identify and map the extent of surface water in lakes and rivers. NISAR can be used to track floods even under vegetation canopies. Floods are important not only for their impact on society but as a significant means for a distribution of sediments on floodplains. Okay, so I kind of read it a bit rapidly, but it's fairly straightforward, and the material, as I said, is directly taken from the JPL website and a couple of other sources, and I hope it's useful. I've added a few comments as far as I know, but remember that I am not a satellite expert, so please follow up if you want more details on any particular details. Okay? All right. See you in the next topic.